there's any problem descriptions that are in a written format right now. At least I couldn't find any. As for William's question about for the first problem, what might cause a TLE, I think it's just if your code has the right complexity, it might be something like input, but otherwise you have to make sure to break out of the for loop immediately after immediately after you realize that you've eaten the entirety of the candy cane. Otherwise, the optimization wouldn't work, and you'll end up with a solution that's too slow. Okay, so then for the third question is you have a bunch of it's asparagus. That's what it was. I thought they were trees, but it's probably the same thing. Um, so you have a bunch of asparagus. And for each asparagus, you know its initial height, which is h of I. It's like asparagus I. You know its initial height. You know the rate at which it grows, which is over the course of one day, it'll increase its height by A of I. And then you know what Farmer John wants for this asparagus, or I'll call them trees from now on. You know what Farmer John wants for this tree at the very end when he stops. And what he wants is for there to be exactly TI trees that are taller than it. So you're given H, A, and T. And you're asked to determine the minimum time at which all of the trees will fulfill Farmer John's conditions given in T of I. And also, or alternatively, if there's no such times that it's ever possible, report that this never happens. So then for uh for uh for Grayson, I'm sorry if I pronounced that wrong. Um,
Yeah.
I I'll get to that, or like I covered that just now. I don't know if I might go over like I can go over it again later, or you can go to the YouTube live stream and wind back a little bit. Since I just covered the part about where there's something sick at the beginning or the end. I hope.
Okay. Thank you.
Okay. So then back to the third problem is we can first notice that if we sort the trees by the values of T of I as like they go from 0 to n minus 1, we can know the final order of the trees, or the final order of the trees in height from greatest to least. Since the tallest tree will have 0 trees greater than it, and like the second tallest tree will have 1 tree greater than it, and so on. And so after sorting them by T of I, we can determine the final ordering of the trees of heights from greatest to least. Okay, so then if we think about so the question got turned in gets changed to you're given an initial array of h of I, and they're now reordered by T of I. They're all like sorted in order of T of I. And after one day, the position h of I will increase by A of I. And you want to determine the minimum time at which h of I is now sorted in increasing order or sorted in decreasing order. So it's just a reframing of the question, but now we don't have to deal with the T of I array since we've already sorted h of I to account for that. So then we think about what does it mean for an array to be sorted, right? If we consider some array, let's call it X. X will be sorted in decreasing order if and only if for each x of I minus 1, it's greater than x of I. So only in this situation can the array be sorted in increasing order. And we can use this fact to our advantage for the trees. As what we can do is we can consider, oh, actually, let me keep this. We can consider a tree I minus 1 and tree I don't I don't know how it can affect the caption language. Sorry. So if you consider trees I minus one and tree I, we can use this fact to determine like to help narrow down the window of time. So what we're going to do is we're going to maintain two numbers. Let's call one of them mn for minimum and one of them mx. And the way it works is we're going to use mn to maintain the minimum time at which the trees could possibly all be sorted in decreasing order. And we use mx to maintain the maximum time, the maximum possible time at which all the trees could possibly be sorted in decreasing order. And of course, these don't necessarily it's like what we do is we'll continue to either increase mn or decrease mx until eventually we end up with a final window of time at which the trees will be sorted in decreasing order. And if at any time mx ends up less than mn, then that means that no solution can exist since we can't have the maximum time be less than the minimum time. So how this works is so let's go back to considering two trees, I minus one and I. And so let's think about it this way. So if we know that tree I minus one grows slower than tree of I, this is what the A value denotes, right? If we know that tree of I minus one grows slower than A of I, then at some point, tree I will grow taller than tree of I minus one. And there's no possible time at which tree I minus one could possibly catch up again. So there will exist some time such that tree I will be taller and it will never be caught up to again. And what this means is that the moment tree A of I grows taller than tree A of or than tree of I minus one, then then after that it's impossible for us to have all the trees sorted in decreasing order, since we know that at this point H of I will have to will have to be oops will have to be or H of I minus one will have to be less than H of I. But we need H of I minus one to be greater than H of I. So after this point in time, it's impossible for the trees to be sorted in decreasing order. So if we can determine this time, we can use it to update our value of mx. And then as for determining this time, we'll get to that later. So and then in a similar logic, if A of I minus one is greater than A of I, there will exist some point t such that before point t, tree of I minus or the I minus one tree will be shorter than the tree of the ith tree. And after this time, it will have caught up. And since it grows at a faster rate, it won't be passed again. Of course, this time may not necessarily exist. It might be possible that at time zero, the I minus one tree is already taller. But if that value is positive, then that means that the answer cannot be lower than this time. Since if it's lower than this time, then we know that h of I minus 1 is still smaller than h of I. So we can use this to update mn. And then as we're calculating that, I'll get to that later. So yeah, so let me rewrite. So then the final case is when the I minus 1th tree and the ith tree grow at the same rate. So in this case, we only care about the initial heights of these two trees. So if the I minus 1th tree has height less than or equal to the ith tree, then that means it will never be strictly taller. Since they both grow at the same rate, the tree on the left will never have a chance to catch up. But if it starts off taller initially, then it will always be taller. So in this case, we can compare the initial heights to determine whether or not it's possible. Oops. And then, so after we loop over all these pairs of adjacent trees, we'll end up with a final value of mn and mx. And we can use, and we, if mn is less than or equal to mx, then the answer is just mn, since that's the minimum time at which it's possible. But otherwise, the answer has to be -1. Or, since there's no possible time at which all the conditions will be fulfilled. The answer is -1. So then as for actually calculating the values, let me erase some stuff. I think I'll just clear it. So if we have so a of I minus 1 is less than or equal to a of I, and we need to find the maximum time at which it's still valid. And then so the no, I mean, no, oh yeah, we wanted to find the maximum time. Actually, I should start with this case since this would be easier. So if we have a of I minus 1 is greater than a of I, we need to find and we need to update the minimum time. So how this works is we have like so h of I minus 1 plus t as in the concept as in time, not taller. A of I minus 1. So it's like this, and we can use some algebra to arrive at the answer. Okay, I'll replace t with x since I think that's easier, so it's harder to confuse with the plus signs. So we can do some algebra. So we have actually let me do this the other way. So with some algebra, we can find the new we can update mn with this value. Since we know that, or I guess it'd be this value plus 1, since we know that the answer cannot be lower than this value. And then something similar applies for the maximum. So this is rather awkward. My pen just ran out of battery. Here, let me think I can get it to work.
Okay, I see one student keep set the translation to Russian. Do you need that really? Okay, I'm sorry, it's kind of annoying a lot of students. Please stop it, okay? Stop playing around, okay? This is not fun.
Then we can use something similar here.
It's working, we can see it's writing. I mean.
Okay. I think my pen died again. Yeah, that's unfortunate. It's fine. Okay, so and then we can end up with the fact that x is less than this value, and we can use it to update mx. There's also a little bit of casework that has to be taken into account to deal with integer rounding to make sure that you round up. And also keep in mind that this final update says that x is less than. So when we update mx as the possible value, we'll update it with this -1. So with some math, we can calculate the exact times at which the mn and mx will be updated, and we can use that to determine the final interval. The total complexity will end up being the total complexity will end up being O of n, since we only have to since there's only n adjacent pairs, and that's all there is for the third problem. Does anyone have any questions? Just keep in mind that my pen is dead now, so I can't help with any drawings or anything. So then if not, uh, uh, I wish I could. My pen, my pen is dead though. Yeah, or like, yeah. Yeah, I would run through a sample case if I could. So I think that's it for the problem explanations then.
Okay, thank you, Weiming. Here we have a summary page I just put into a slide, so it's easier for the student to capture. Maybe how about you give the summary here? Yeah, just summary these three problems. Weiming, can you see my screen?
Yeah.
Okay, yeah. Just a quick summary about this problem, the knowledge used, especially the correspondence to the courses in XCamp.
Yeah. Sure. And then the first problem focuses mainly around gradient math. Uh, the second problem is mostly greedy problem, and the third problem is about sortings, not necessarily geometry, but definitely math. And yeah.
Okay, thank you. You can see this corresponding to XCamp 102, 200, 202 classes. So if some of you attend XCamp class, it will help you to solve these problems. Yeah, if not, we are happy, to see if you join our classes. In addition, here we have we try to help each student to analyze your your performance in the this USACO contest. We have a form here. I just typed in the chat. Please click this form and submit your score, so you can receive a kind of evaluation report card like this. So if you want to have, also please join our Discord, so we can have more discussions, especially for the future contest too. Yeah, everyone here, please click the form link, submit your score, so you will get a report card. In addition, please click the Discord link to join our Discord channel. Okay, sounds good. Let's see if I have any questions here. Yeah, please just raise your hand to ask questions. There's annoying kids I can mess up the chat. This is not fun. Okay, please don't do that again.
Wait, do I even have to fill out the form?
If you don't like to, it's okay. If you don't like this report card.
By the way, I am not in XCamp.
Yeah, this is not for XCamp student only. If you are not in XCamp, you are kind of recommended to fill in this kind form so you can get a report card. Yeah.
But do I need to?
No, it's not required. It's recommended.
But does my mom want me to?
That's this between your mom and you. Okay.
She did not tell me.
What? If your mom asks you to do so, if you want to follow her instructions, you would like to follow. If you don't want to, that's kind of your decision. Yeah. We are just here to help you, to try to help by analyze your results and give you some suggestions. Yeah. Okay. Any questions for these three problems? No? Okay. Also, we have our assistant, Alex Du. He's here too. He's also a USL Platinum Division achiever. So, Alex, do you have any comments? It's good.
No, I think we did a good job covering everything.
Okay. Okay. Great. Last call. Any questions? Any questions?
Oh, for the first problem, I think you can go to the YouTube live stream and wind back a little bit. I covered it there, and it's recorded already.
Yes, let me share with you the YouTube channel. We have a live stream too, so if you missed, you can go there and check the previous explanations. Yeah.
Okay, so as for the complexity of the third problem, it should run in O of n time, or I guess it's O of n log n time in total or O of n, depending on what you use to sort. It's possible to sort it in O of n time, and it's also possible to sort it in O of n log n time. As for the cutoff isn't announced, and I wouldn't know anything about the official thought process that goes behind making the cutoff. But just my personal opinion, doesn't weigh on the actual cutoff. But I don't think it'll be any higher than 750. But that's just my own thoughts.
Okay, sounds good. Yeah, if you like to send your code, you may send like your score and send us email, so we can maybe share the code with you too. In addition, I see a parent student ask, what's the USACO enhancement class in us? For us, we now we call it a markup test. It was originally called the enhancement class. So every week we have a mock test. We have from October. Now from the future ones in January, February, and March, we have a mock test every week, except the USACO contest weekend. We don't have that. So we have 3 every month in the coming 3 months. Yeah, if you are interested, you want to improve your coding skills, you want to pass some levels, please join our enhancement class. Now we call it a markup test class.